At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Welcome, everyone, to the Simio Solution Series on April the 23rd here. Let's get right into it. So today's session is Building Blocks of Simio Modeling Part 3. As hopefully you saw in the email that went out to invite you to today's session, you did not need to attend sessions 1 and 2 or parts 1 and 2 to attend this session. But we do highly encourage you that if you haven't attended parts 1 and 2, they are on our website. I will show you here in a minute how to get back and review those for future purposes. My name is Dan Vaslini. I'm the VP of Global Sales over here at Simio. Doing most of the talking today is going to be Drew Rose, one of our solution engineers. You'll see the QR code there on the bottom left side of your screen. As I mentioned in every webcast, and you'll hear me if you go back and watch the recording, we're always looking for feedback. If you could scan that QR code, give us some feedback on today's session, as well as any type of future ideas you may have for sessions. We are always open to ideas. All right, a couple housekeeping items before we get started. Today's session is being recorded for replay purposes, like I mentioned. This session, as well as the prior 2 building block sessions, are on our website, as well as every prior solution series we've done. So we've got dozens and dozens of them out there now at this point. The way to get to them under the resources tab on the Simio website is the Simio Solution Series. It's the first drop down. You'll see that kind of highlighted there on the top right hand side of my screen. You can go in there and simply go in and watch any prior webcast that you so desire. You can watch them at any point in time. On today's session, please be aware also that you will be muted for to prevent any background noise. If you do wish to ask a question, somewhere on your screen there should be a WebEx panel with a QA area. In that question and answer area, you simply type your question in. I try to ask those questions when most relevant, whether it's on a specific topic that Drew might be talking about. If I can interrupt him, I'll ask it at that point in time. Or if it's more generic in nature, we do hold some questions to the end, and we will ask them all at that point. We try to get to all the questions. I know I talked to Drew, and his session today is probably going to run about the full hour, but we always try to leave time for questions. And if we don't answer all the questions, I will flash our emails up at the end one last time, just in case you didn't get your question answered and you want to reach out for something. All right, future sessions, so that everyone's aware. Oops, there we go. We have our next 2 planned. So this is April. You'll see a month skip here, and I'll explain that month skip in a second on why we're doing that. But June 18th and July 16th, our next 2 sessions. You can read the titles there. Give it a second for you to read the titles. And then, as I said, so we are skipping May. The reason we're skipping May is Simio Sync is occurring in the middle of May. If you attended last session, when we announced Simio Sync, we announced it as May 14th. We're actually going to do a 2-day online content now. We have enough content that we didn't want to squeeze too much into one day, and we know sitting in front of the computer all day watching a conference might be a little too much. So what we're doing is we're doing 2 sessions with content each day. We're going to run from around 9 a.m. in the morning till around 1 o'clock or so in the afternoon for everyone to come in and watch. And as I said, it's live online content, so you will see presentations followed by live Q&A during that session. To sign up for Simio Sync, you will see right on the Simio webpage a big banner for signing up for it. Feel free to go out there and get registered for it. It is a free online conference, so we highly encourage you to get signed up for it and get out there and join us here in less than a month. You can also see the overview of Simio Sync. We are announcing presenters as we go here. I think we have our final content all ready at this point and our final presenters all ready to go. Pretty exciting lineup with some big names and some companies doing some very unique things. So we do highly encourage you to join us in the middle of May. All right. So once again, thanks for attending today. We do appreciate everyone's attendance at all these events. We do like putting these sessions on, and the more we get content and feedback, we will keep doing these things as long as people want them. I mentioned earlier the QR code. You see it on there right in the top right-hand side of the screen to give us any type of feedback on today's session and any type of future session content that you may so desire. All right, that's it for me. I will turn things over to Drew. Like I said, I'll be here to ask questions along the way. If you have questions, please type them in. We'll get them addressed when they come in, and we will also hopefully leave time at the end for questions. And as I mentioned, if you don't get your question answered, I will put our emails up one last time as we get to the end. So thanks, everyone. And Drew, the floor is yours.
Thank you, Dan. Say good morning, good afternoon, good evening, wherever you may be watching. Glad to have you here. As Dan mentioned, my name is Drew Rose. I am a solution engineer here with Simio, so I work with our prospects and our customers, and looking forward to discussing today part 3 of the Simio building blocks. And certainly, if you haven't seen the first 2 sessions of this series, I highly recommend. But we'll touch on some key topics that extend beyond what we've seen previously, and we'll explore what else is capable as we start out with some foundational pieces to modeling within Simio. So I'm going to share my screen and we will get started. So as I mentioned, this is going to be part 3 of our series. And a few topics we'll cover today, not the exhaustive list, but some things that you'll see as key takeaways. We'll touch on custom objects, output tables, dashboard reports, the use of model trace for debugging, process logic, custom tokens, and experimentation. So these are some things to look for. And certainly, as well as Dan mentioned, as there are other questions that may come up on any of these topics or anything we discussed today, certainly we welcome all of that to have a longer conversation related to those items. So I will get started and then we will see where we get today. So as you mentioned, this being part 3 of the building block series, if you've seen the previous 2 instances of this series, you'll recognize this model as what was built to this point. So we have a machining operation with 3 different finished goods that go through the system, each of which have their own unique routing through the system at some of the various machining operations. So we'll pick up largely where we left off, and we'll touch on how we would extend this a bit further, more on the data-driven side of things and getting some more insights related to model performance. So as we run this model as it stands, how it'll operate is we'll have our product flow based on a historical mix that will operate. And if I expect the speed here, we'll see that our products will flow. And as we were seeing in the previous instances, we have a lot of tracking capabilities that we can see where our different products are moving and get some different insights on the movement through the system in that regard. And as we ran, we saw that there are 3 different products or 3 different machining families in this particular operation, each of which serve a particular purpose within the confines of the routing that has been defined. So just to refresh a little bit from previous sessions, there are the 3 different finished good types, each of which have their sequence through the system. So each widget A has its own unique 4-step routing, widget B has its 3-step routing, and the same could be said of widget C. So that's where we are speaking. And if there are topics that maybe you want a bit more information on that I'm going to gloss over a bit, feel free to reach out to us certainly as well, or watch those previous sessions to get up to speed. But now taking that and where we left off and expanding, what we'll touch on today is, in this case, what we historically built was all of these are server objects. So each of these represent a server instance, but with the animation capabilities that Simio offers, we see that the turning stations here have the lathe animation to them. The milling has their own animation, and the same is said that of finishing in that case. So this is where we can take the base class of that particular object, But when we want to, maybe in moving forward with this particular model, maybe we want each of these objects to be readily available to us as a user. So our standard library is largely where our model has been built from to this point. But as we talk about having a templatized model or something that is going to be scaled out as you expand your Simio modeling, that's where the use of a project library may be of benefit for that end user. And we've built hierarchically various models throughout these sessions, so you'll see those appear here. But there aren't any single custom objects to that. And when we would want to do a custom object is where we have an object that has a certain behavior feature set to it that we want to have readily available on the object, as opposed to needing to do customization each time we go and create a new instance of that object. So from the previous session, we showed a little bit about being able to reference a table of tasks to find the information related to how this finishing station is to behave. And when we go into that repeat group, we see some of those mappings taking place. So just a refresher, these are all reference properties. So when this finishing station has a particular product that it needs to work on, we know that it has the reference to these various stations to find that information. And so let's say we've come to the conclusion that this is going to be how the system would be, how these machines would behave moving forward. That's where we would then want to be able to make this a custom object so that as we introduce a finishing machine moving forward, we're already going to have these references at our disposal, as opposed to having to go create these references each and every time we build a new machine. So extending that, that's where we'll go and customize that. But additionally, today we want to consider the prospect of maybe there's going to be rework that is needed at each station. So at the conclusion of a task, and going back to that task table, what we want to also perform is an evaluation of whether or not rework will be needed at the conclusion of that station. So to do so, we're going to add a few more columns to help aid in that process. So that's where I'm going to add a column in this particular case, and that is going to be our rework rate. So this is the percentage to say what percent after the conclusion of a particular task is the likelihood that it will ultimately need rework. I have a few data points that I've already built out just to populate this with. So when I go and pull those scrap rates, or those rework rates rather, this is going to be, and this is overall a percentage, but we're going to evaluate this percentage each time a task has concluded, and this will help to determine if a product will need rework or not. Then as well, we're also going to need a process to help aid in that particular rework operation to determine whether or not rework is going to be needed. So that's where we'll add a process element, and that's where we're going to ultimately get into process logic. So to make this evaluation, we're going to extend the logic beyond the defaults and make use of these processes. So this is the first time seeing process logic. Very similar look and feel to the facility view in that it is kind of your drag and drop paradigm. So in this case, I'm going to do a rework process. So to do so, I will name this my rework check. And what this hopefully is going to do is that at a particular cadence, we're going to run through this process logic to evaluate the validity of a rework being needed or not. I'll start out with a decide step, and this is one of the more common steps used in process logic, where you can have a certain condition or a probability of an event taking place. So I'm going to rename this rework needed, and I'm going to pose it as a question. And I need to spell that correctly as well. That would be beneficial. And when we're going to use this rework needed, because we have that reference in place based on some of the models the model work that has been done to this point, because on initialization, we're already pointing to a particular row of what product we're working on, as well as what task we're working on, we can use that row reference to be able to specify that process in this table. So I'm going to call this the rework process. And then with this rework process, I'm going to populate at what process should be performed at a moment in time. So I'm filling this out. And then the next step, we'll need to also finish out the process itself. And then as well, when should this process be evaluated? So to do so that's where we'll go in and take our custom object definition. You'll see also subject to these particular objects are these process triggers. So at the conclusion of a task, this is when I want to perform the evaluation of whether or not rework will be needed. So at the finishing task process trigger, and there's more literature on when all of these occur and when you may want to use each of these specifically. But when we go and add in this rework check, actually, we will actually point to our table to do so. Based on the task information we have, we're going to point to the table column of what process should we be working on. And because we just populated that with the rework check, that will ultimately determine that the rework check should be evaluated for this specific machine when a product has finished its particular task. And maybe this is that process will be carried out for all other servers. And that's something where we would then want to be able to customize those so that we don't have to go in each and every time and make that assignment. So based on this evaluation, based on this new rework process I've added, that's where I want to go, and I'm going to right click and I'm going to create an object from this. So I'm going to call this a new custom server. So I'm going to call this the finishing machine. So with the finishing machine, we see now that up both here in our object definitions as well as our project library, I've created a new object instance, that of a finishing machine. So now we see that those bolded properties that we saw previously are now no longer the case, because these properties that we previously defined now are adopted as the defaults for that object. So anytime we now introduce a new instance of that finishing machine, we would expect that these properties will come standard with that particular object. So we've created one finishing object as the base instance, but then I want these to also be converted to that. So stations 2 and 3, that's where I'll then also convert those to a finishing machine. So when we do that conversion, we now see that those properties have then been no longer bolded. When I go in and see, we also need to make the check. We also need to make that reference here just because they were already introduced prior to making these a custom instance. So we'll do that here, but moving forward, we will see that those instances will have these new properties assigned to them. So with this custom instance now, if we go to add in future instances of our finishing machine, we see that we have those added in, and all of our different tasks are readily assigned to that object itself. So now moving forward, and we'll see in the coming period here, when we go add in brand new instances of this, it's going to be very nice as the user to have these properties defined instead of having to go into a repeat group and make these definitions each and every time. And Dan, I'll pause there. I know we are in the beginning stages. Just want to check in to see anything that has come up to this point.
Yeah, I think you might have just addressed this, but just to make sure, can you create a custom object across different models, or you need to recreate the custom object every time?
No, so the custom object will be built. You can build that in one model, and then if I were to go and work hierarchically in any of these models, since I created this as a separate object, these would be available in each and every one of my models.
And what about creating those custom objects through auto-created tables, or can they be auto-created through tables?
Yes, and that's what we'll touch on that in the coming time here.
Perfect. Leading question.
I always like those. All right, well, we will forge ahead. So now that we have our custom object instance and we have the definition of the task that we wish to evaluate, we're then going to also, and we'll focus today on the finishing machine, but then as well, I also want to have those tasks be defined at these other stations. So I'm going to go add in that same task over in our other areas, and I'm going to make that a rework process. I'm going to create my own custom turning machine. And once again, spelling has been the bane of my existence to this point. But we will get that turning machine evaluated, and then we will make that proper change to our other stations. So I want to convert these to turning machines, which we'll do. And then we can go and make sure that those changes have been corresponded. And as I mentioned, because these instances had already existed prior to me making that custom object, we won't see that change here, but we can make that reference. And then going forward, as we saw, we dragged out a new object. Those would appear in any new instances that are introduced to the model. So we'll finish that out here. And then we'll do this operation one more time for our milling station. So we're going to go in for my milling station. I'm going to create a custom instance of this as well. So with that change, I want to then go create an object. And then I'm going to carry that change over to create or convert that to my milling machine. And there we go. So now with all those changes in, and the rework is now being evaluated, that's where we can finish out that process logic to make sure that this check is being done properly at each location. So when we go to this particular station, again, using the context of our row references, after every single job that is concluded at a station, we're going to be evaluating this rework check. Because we have that row reference of which task we are actively working on, we can point directly to this table column without having to hard code a specific column or row number to find the information we're looking for. So using this information, I'm going to use a probability, and that probability is going to be determined by our table tasks, we'll make a reference there, and then our rework rate. So that's another point, is especially as you're building out process logic, in the beginning stages of using it, there may be a tendency to want to instantiate specific rows. When you have these row references being used to your advantage, that allows you to be generic in nature as far as how your process logic is built, so that you can scale this to be applicable to any particular row throughout the table. So really a time saver as far as logic is concerned. And that's something that comes with a little bit of time, but is a strong modeling practice when put together. So if we go in are deciding whether or not process logic will be needed or a rework will be needed, then if that is the case, we will then introduce a rework rate, or a time that we'll be reworking for. So we'll call this our rework step. And this delay is ultimately going to delay the object from the entity from moving for a period of time. So just for our purposes today, I'm going to say that based on the nature of the rework, it could be captured with a triangular distribution. So anywhere from 30 to 60 minutes is going to be how long we're going to be performing that rework at the station, and then it'll be able to move on from there. Then as well, also, if a entity does ultimately need rework, I'm going to add in a state that allows me to tag a particular entity for being reworked or not. So if it's reworked, we'll add this in to our process logic. So now we'll use an assign step where I'm going to say, let's tag that entity as reworked. Then using that Boolean I just created, I'm going to say, here's the state, and I'm going to categorize that as true. So this entity now is going to need rework, so we're going to tag that as true, and we'll make use of that later on for what this can mean for some statistics that we gather. So that's just how we would start this particular case. So now, using this, we'll make sure that our logic is making sense. So that's where we'll deploy model trace to help aid in making sure that what is being evaluated is correct. So when we run this, now we see that the model using this breakpoint will stop the model at strategic instances to be able to evaluate more closely what is going on in that particular case. So we see that widget B, ID number 38, is about to perform a rework check. And we see that it is at the turning station. So turning 2 is the task that's being performed. So when we go to the particular model, now that we see that this is the case here, we have widget B 38 at turning 2, has just concluded its turning task. And now it's going to evaluate whether or not rework is needed at the conclusion of that task. So when we run this, we determine that based on the minimal probability, it is going to be determined that it does not need rework from there. So that's going to go to false, and then it'll be able to carry on its routing from there because it does not, in fact, need rework. Moving that breakpoint, now I'm going to put it on this delay step. That's going to assume that a task has ultimately sampled to the true branch of this particular task. So fast forwarding, now we see that we've moved about 28 minutes, and now we see that widget A has actually sampled to be true on this 0.3% chance. It is going to require rework, and now we're going to see for how much time will it ultimately be in that rework phase. So that's where we'll then use that delay step. It's going to be 0.75 hours approximately for how long it'll be in that rework phase. And upon the conclusion of that task, and I'll move that once more. Upon the conclusion of that task, we then see that we are now assigning that widget to be reworked. And once more, we'll use this more later on for further enhancements. So this is the kind of how you can start enacting process logic and when it would be applicable. So for something that is probabilistic or something that is unique to each particular task, this could be a very viable process to help aid in the logic beyond the defaults. So that's a first example of where that could be applicable. But maybe we want to get a little bit more granular as far as the detail to this. Maybe we want to have a log of these rework instances and some behaviors and information that defines when these are occurring. And that's when it would be a good candidate to consider an output table for additional logging capabilities. So with that in mind, I'm going to then create an output table. And these are really useful to be able to capture information in the model beyond what is default and be able to use that in meaningful ways. So I'm going to create a table for rework. I'm just going to make this my rework report. So in that particular case, I'm going to get a few different attributes that help aid in defining those behaviors. So I'm going to create a string property. So I want to capture the ID number of the entity itself. So which particular entity failed. I want to capture the time of that failure. So I'm going to say the time. I want to capture what product family is that a part of. And because, again, we have these row references, I can use a foreign key state. And I'm going to ultimately point back to the table of products. And whatever product this ends up being is going to automatically write to this particular row due to those table relationships. So that's going to be the product. And then again, I can use that also because we also have a reference to the table of tasks. I'm going to say which particular task are we working on. Then I also have to define which table to point back to. And then lastly, we'll just have an object reference to say what station uniquely did this occur at. So I'll say my station, and then I'm going to also have to write this out to say at what particular station did this take place. So these are some attributes that I wanted to capture beyond just having the rework. I want to additionally report these statistics related to that. So that's where we will go back to process logic to do so. And we'll add in a few other steps to make this a little bit more intriguing. So the add row step is going to be useful for our output table. So I'm going to have a new entry. And when we have these instances of a rework being needed, I'm going to go to that table of reworks, and I'm going to add in a new row to that particular table. And another point to note is that because there is the possibility that one entity could be reworked multiple times, we're also going to want to have this be defined to a particular token. So this is a little bit more technical, but having this go to the token is this token is, so if one entity goes through its routing and this check is performed each step, a unique token will be generated per instance of this being evaluated. Whereas let's operate under the assumption that one entity failed every single station. Because we're generating a new row, that entity is going to have an initial row reference to that first row that it created. So if it failed at the turning station and it had a report written, that entity, as it moves along the system, is still going to maintain that reference to that first row. And so when we go to add new entries off of that, you'll have a row discrepancy that you'll want to avoid. That's where the token will be beneficial in that particular case. Again, this is a bit more technical, a little bit more advanced, but for our purposes today, it's going to be useful for building out a report. Then as well, I'll add in a few more steps and just save a little time. So we'll add in our ID number, and we're going to write the model entity.name as the ID number. The time of occurrence, we're going to say, let's write to that report and capture time now. And then the location is going to be the station. And again, because we have those references available to us, since this is happening within the confines of one of our objects, the context object of where this process occurs is going to be inside of that particular object. So this is going to evaluate to a name of a station, and we'll see that that will be captured in our report that we gather. So with all of this, we've now done our rework check, and now we've added in some logic to help write to an output table to capture all those instances. So now when we run this forward, and we'll run this for the duration, now we get a rework report that can be used for us. And also, I want to use the task key. I used the wrong one here. So let me run that one more time. Oop, I get a free rotation. We'll run that here. And now as part of the output, we have all those evaluations be done, but also as a rework is needed, we're now getting this additional report that says what entity failed, what time did that occur, what product family is it a part of, what task did it fail on uniquely, and what particular station was it at when it failed. So this gives us a breadth of information beyond what we would have otherwise. And now this, when we get into some dashboarding down the road, this can be useful to us to get some meaningful statistics in different locations and things to that end. But once more, I'll pause again, Dan, to see if there's any questions or things additionally that have come up, and also to give me a chance to get a swig of water.
All right, I'll read the question slow then, so you can drink slowly or quickly. How would we model rework that requires the entity to go to a different station and then come back or continue on the line?
Sure. So much like we have our table of routings here, depending on the nature of the rework, there are some instances where a rework loop has multiple phases to it, multiple tasks, multiple stations. In that workflow, there would be a similar setup to how we have our routings. And then based on if it needs to go perform rework, we would modify our sequence to be cognizant of that rework then. So we would route it to our rework sequence. And then upon the conclusion of that, we would get it back onto the particular sequence. So that's the general way in which you would do that. If there are certain specifics to the environment that they have in mind, I think that would warrant a further discussion offline just to get a sense of the nuance for that particular condition.
Okay. And I think this question might relate back more to when you paused before and asked if you had any questions, but let's ask it anyway. What is the difference between the add-on processes in the task repeat group and the add-on process in the server's property outside the task repeat group?
Great question. Yes. So, and this is still rotating, but let's turn off that rotate. So inside of a particular task sequence, these process triggers are useful on a task-to-task basis. So if I had n number of tasks here, these would all be local to one single task. Whereas outside of that repeat group, these are more so on a general sense. So this is going to be upon entering to the object, independent of any particular tasks, processing would be capturing the beginning phases of a particular operation, but not necessarily going to be having the granularity needed to look at things on a task-by-task basis. So the general rule of thumb is if you have multiple tasks and there are particular operations that need to occur on a task-by-task basis, the best structure would be to have the processes internally hosted. Whereas maybe if you have a single task operation or something that is more globally held at the object level, that's where you'd want to make use of the processes in the object itself. So a couple of points of distinction, but certainly use cases for both.
Okay, perfect. That's all the questions in the queue right now.
Very good. We will forge ahead. Okay, so our table report has been generated. Then as well, also, if we want to be getting an indicator of those failure instances, we can then see in our Gantt, which is brightly colored right now, we can see all those different rework loops. Those are ultimately going to be the time consumers. So this is just another visual indicator of all those rework instances and when they occur. But also off of this, in this particular case, there's not any visual indicator as far as what product failed and where was it at. And that's where we'd want to add in a little bit more to our log to help be able to give this a little bit more color-oriented look and feel to aid in our visualization. So to do so for that, I'm going to add in a color property to this particular product table. And what this is ultimately going to do is these are going to be the colors that show up on our Gantt when we produce those end results. So I'm going to name this the color. And then I will give each product family its own unique color in this case. So I'll just go, we'll go crimson. So roll tide. We will add in a little bit of yellow. And then we will go, let's go royal blue. Yes. So we'll add in these three colors. And using these, we're going to be able to characterize these as the colors I want to display in the Gantt per part type. That's where we'll go to our logs and kind of another behind the scenes. These Gantts are ultimately used by the resource usage log. So the resource usage log behind the scenes is helping to populate that Gantt with the information it needs to perform its visualization. So when I want to add in a unique color per product, that's where I'll add in another column to this log. And then I'm going to call that one the, it's going to be just my color log. And then I would do so there. Then the expression that I want to define, if I want to define this to be on the entity basis, I will need to say the owner of that particular object. So the entity is seizing the capacity of that particular object. So I'll start my syntax with owner. And then because we have that reference to the table products, I want to then point to table products, and I want to point to the color. So depending on which entity it has a row reference to, find the color that it corresponds to, and display that as the color for that particular entity. And then I'm going to use that as the Gantt color. And then as well, I'm going to just give this a meaningful color, a meaningful title. This is going to be the Gantt color. So now previously we saw that the colors are arbitrary as it stands now. When we go and run this further, now based on the coloration that we've provided, all of the red and all of the widget A's are going to have a crimson color to them. Our widget B's are going to be yellow, and our widget C's are going to be royal blue. So now that we see things move through here, helps to give us a little bit more visual to see what products specifically are flowing through. So our widget B's, we see that they start with yellows, and that helps to aid to see our product flows. And especially if there are considerations down the line of changeover logic or things like that you're enhancing, being able to have the colors mean something is going to be really beneficial for Gantt visualization. So just another little note there as far as getting your feature set available to you. Adding in those Gantt colors is a nice add-on to have the resource Gantts have a little bit more meaning. So that's another point, and this is, again, just aiding in our suite of information available to us. What we then want to also evaluate is maybe we have our table report of reworks. Maybe we also want to see how long our time in system is by product. So that's where we're going to, again, use another output table to our disposal. So adding in this output table, this is going to be our time in system report. So similar common thread there where we're going to add in an ID number. So I want to see by entity. I want to see what product is that a part of. I want to know the time in system. And I'm going to have that be displayed in hours as it is. And then as well, we're going to make use of that previous rework state that we had. I'm going to also tag it if it was reworked or not. So when we ultimately track this, another built-in function of Simio, one of the expressions, is that at the input of shipping, I'm going to capture and write out a new entry at that moment in time. So as an entity enters the shipping department, I'm going to add in some new logic there. So I'm going to use a add row step. So I'm going to add in a row to the time and system. I'm going to add in the ID number, so model entity.name. I'm going to add in the time and system. So that time and system is, again, another syntax where we capture time now minus the time that it was created. And this is another function that was built, it's built into the entity's definition. So this is going to capture the difference between when it's entering shipping and when it was created. And then we're also going to use the decide step once more. So the previous decide step was probabilistic. This one is a condition. So this condition is going to be whether or not it is met or not. So if that entity has been reworked in the past, since it was tagged true here, if it is still holding that true definition, that's where we'll then go and have that also have a tag to say it is true. So we've added in a second process string now. And this one is, again, similar train of thought, capturing more output logic, but is doing so on the time and system basis. So now when we run this one through, again, running through a day's worth of production, we now have two separate logs to our advantage. So we see that our get a time and system report. And then if there's any reworks that are being done, this is going to capture all of the rework. So what we're taking from this is that clearly, as the day goes on, the time and system is far, far, far too large to be satisfactory for the system. So based on that, maybe we want to examine what can be done. And that's where we'll turn back towards those object definitions that are available to us, and we're going to make use of those. So when we run this through, we'll see that our finishing stations relative to the others have far bigger queues to each of them. So there's a significant capacity constraint. And based on those custom object definitions, we want to see should we add more of these finishing stations. So actually, we're going to pivot in this particular case, where we've done these drag and drop instances, but when we talk about, and this is from one of those questions earlier, when we talk about auto creating instances, we can data generate these objects. You're not limited to just having to pull those in from your project library. So I'm actually going to delete all of these object instances, and we're going to have a table define these. But then as well, we see that these errors show up. That's because we also have a list of finishing nodes, but we're also going to do away with that. So now I've already, and for today's purposes, I already have a CSV file that is referencing some table definition for how we're going to create table instances. I'm going to create a new table, and I'm going to have these be my table of finishing stations that are set to be prepared. So I'll give it a name here. And another powerful feature of our data bindings is that you're not rigid as far as what your schema may look like. So because I already have a CSV file that defines my object characteristics as well as their relevant coordinates, I want to pull that schema in as is, and then I'm going to adjust it in Simio to get it to work how I intend. So I'm going to create a binding, and I have a CSV importer that I want to make use of. And then I'm also going to, making use of this importer, I'm going to provide the folder and file name that I want to pull in. So I'm going to go into find the folder that I'm seeking. So I'm going to go into my solution series data. I'm going to build in my demo. I have the folder located in my demo folder. So this is where I'm going to retrieve the file from. Then as well, I want to say, what file specifically do I want to pull in? And that's where I have four different CSV files that we'll go through. But I want to pull in the default, the one that we had 3 servers previously. That's the one I want to pull in. So when we set that up, I'll pull that in, and then you see that when I import this table, the schema that is already in the CSV auto populates inside of Simio itself. So certainly if you're thinking about integrating systems on your side, bear in mind that depending on the nature of how your data systems are architected, you can pull those in as is, and Simio is flexible enough to adapt to that schema and make those changes. But with this, we need to make a couple configuration points, because this is going to evaluate and determine, since this has text, it's going to evaluate this as a string. We just want to make a few modifications to get it to work how we are desiring. So I'm going to use some change type behaviors. I'm going to want this to be an object. And when we go, I'm going to want to auto create instances of these finishing machines. I'm going to use the type column to define what particular station am I working on. That's going to be a finishing machine. And then as well, using that previous node list, another little tip is that you have the capability to make these node lists for routing purposes, but also a node property, and I need to change it to 1. A node property column inside of a table is also a viable node list for all intents and purposes. So right here, this finishing node is looking for that node list that I deleted. If I go and actually point it towards this table column name, it is going to show up as a viable list. So now the error has gone away. And so now the list is going to look at all of those columns that are created, and it's going to generate one for each instance. So now I have my different coordinates for all of the different machines. Then as well, I also need to define these columns to be where the coordinate locations should be referencing. So I'm going to say that to find the object's X location, reference the X location column, and for Z location, reference the Z location column. Now, upon doing so, we see that our object instances have been created, and they are now data generated in nature. So these are all going to reference our object data table to find the information that's needed. And where this ultimately is going to go is that maybe we want to determine adding in more stations. So I'm going to have a few different configurations where we're going to pull those in. And I'm going to name these each unique, and we'll see what that ultimately is going to do for us. So we have 4 different configurations that we can work with. And for each configuration, I'm then going to define what CSV file should it be referencing. So this particular case, the for server behavior, I want it to map to a table that I've defined. And then the same could be said of the 5. I want to make that configuration. And then once more for our 6, we'll pull in the 6. So now with this, I'm going to then pull in, let's say we want to run this model, but now with 6 stations. Again, I have a CSV file that accommodates this. But now when I go and run this with the 6 servers, I can pull that in. And now the 6 servers are going to populate, and they're going to be located in the model itself. So now I can start to work with that flexibly. And then as well, because this station is looking at the table of rows, this allows the node list to be more scalable, as opposed to having to hard code the number of stations each and every time within a list. It is going to adapt to how many of these stations are active in the rows itself. So very flexible in nature. I think it's a big advantage to, especially as you're considering adding in capital equipment and things like that. Having these be data generated is going to be a significant time saver in that regard, to allow you to test out various configurations and policies in an agile manner. But once more, I will pause for questions and see where we're at.
Okay, we got a bunch of questions here, Drew. Let me go through a couple of them. When do you recommend using state columns in a table versus creating an output table?
Yeah, another great question. So both are viable options. I'd say a state column is usually more so for, at least for my personal usage. I use an output table to get entity level outputs and entity level information. So in this case, all of these rework reports tie back to single instances of an entity's behavior. Whereas a state column on a table itself, or on a regular table, this would be more tying back to a particular object. So maybe it's a object definition. So if I wanted to write to this table to see the throughput at each of these stations, since this is a object definition, you can categorize these more holistically. The same could be said of your table products. If I want to see, similar to what was done previously with Kiara's floor labels, if you want to see the movement of the products themselves in their totality, that's where a state column on a property table would be more viable. Whereas these are capturing instances of those product definitions. So it's far more individualized as far as an output table is concerned. If you're looking for entity by entity behaviors, that's where you would really see the benefit.
All right. Let me ask one more here in the queue, and then we'll get back to you. Can the resources on the Gantt chart be categorized to maybe be displayed in a different order or in subgroups?
Yes. So on each object, there are, under the advanced options, there are display categories, display names, display colors. Those are flexibly deployed so that you can categorize by a product family. You can use these to your advantage, yes.
All right, there's one more question in the queue, but let's go ahead and continue on. I'll save this one for the end.
Very good. So with all this information available to us, now we can get a few different insights related to the model. So maybe if I wanted to look at the time and system in the impact of that, that's where we can use this configuration now for the genesis of experimentation. So Now I'm going to go and create an experiment. I'm going to keep it rather simple for the time being. So maybe if I just want to look at summary level information on time and system, and that's where I'd go look at shipping, input buffer. And again, this is, or rather, I'm going to look at time and system, actually. Again, another one of our standard expressions that come with Simio. So certainly if there's a little bit foreign to you, certainly reach out and we can talk through some of the expression builder here. But I want to test based on all of my different configurations, how is that going to impact time and system? So just a simple experiment, testing out varying quantities of those finishing stations. And we want to understand what impact does adding capacity do for our time and system. We saw that first scenario with 3 servers that the time and system was significant. So the hope would be that adding in capacity is going to lend itself to lessening that time and system. So when we go and run this, we'll get started here. And as it runs, all the while, we see that we're going to have the initial scenarios is creating a significant quantity of entities. But eventually we'll see that there is a reduction as far as time in system is occurring. So as this runs, maybe this is causation that this scenario should be extrapolated out further by each object group, because of this time and system in the hours basis is seeing that there's going to be significant queues being built up based on the amount of demand coming into the system itself. But the general premise remains that as we're testing through adding in capacity, we're seeing a general reduction in time and system. So there is some value in adding capacity. So I'll cancel that just for our purposes for the time being. Then I know we have a few other minutes remaining, so I'll forge ahead, Dan, but if other questions come in near the top of the hour, certainly we can field those as well.
Let me ask one here real quick, Drew, just since I don't want to lose anyone here. Can we create dashboards in the experiments using output tables recreated in the model directly, or do we need to write the output tables to Excel to do more analysis?
Yes, so, and that's where time is quickly becoming my enemy, but that's where we can go and those dashboards become really useful. So if I want to go and create a rework dashboard, categorizing that information that we captured, that's where we'll go and make use of those. So if you've worked with dashboards at all, you'll see that there are usually the log dropdowns available to you, but also your output tables become another option for dashboarding. So if I want to take my rework report and I want to make some logic off of that, I'm going to just create a pie chart to see of all the reworks that are being done, what product family are most of these reworks being a part of. So I'm going to create a pie chart, and for the values, I'm going to say based on which ID it is, I want to see what product is being done in that case. So once that is prepared, we will see the count here. And what we get as an output is going to be the breakdown of each different product is going to be defined by based on what we captured in our report. We're going to see based on the percentage of each occurrence, we're going to see that some occur based on widget A, but the vast majority were occurring as a part of widget C. And then as well, we can build out a grid that shows a little bit more definition for each of those. And that as well being subject to time, a couple of other reports that wanted to show as well. You can also build in using that time and system table we gathered. We can capture that average time and system by product. And then as well, if we want to look at what the time and system is overall, but then if we want to remove rework from the occasion, we can get a sense of what impact does rework have on our time and system. So you can see the y-axis is slightly being adjusted. But if we want to look at solely the time and system based on the reworked entities, we can see that the time and system is significantly increased by those products.
Hey, Drew, he's following up here. You're doing this in the model, correct? Question mark. Is the answer no for being able to use that data in experiments?
So yes, you can use that information in experiments. A little bit more configuration is needed because that ensues replications, and you would want information per replication. Short answer is yes, but I would recommend to follow up a little bit further, and we can talk through what that approach would look like.
Okay. And for the person that's asking the question, I will put our emails up here when Drew's done, so you can reach out to us directly.
Very good. But I think overall, I think that's a good place to stop for today. Certainly don't want to rush things at the end, but other questions, Dan, or anything else that is in the chat?
Yeah, there's one quick question here, and it was, can Simio calculate percentiles in experiment?
Yes. Got into some configuration, but yes.
All right, perfect. All right, let me grab control here just to put our emails back up real quick, just so that the person that wants to follow up, if they do want to follow up, it sounds like they do, can reach out to us. Maybe. Where'd it go? Hold on. I'm trying. Share. All right, there we go. I'm not going to go to present mode, so it doesn't matter. So there's our email addresses for the person that asked the question that we did not get a full discussion, or that we had a discussion on, but you want to go further. Feel free to reach out to both of us, and we will get back to you. If you did ask a question during today's session and we didn't get to it, I do apologize. They were coming in pretty quickly. If we missed a question, once again, feel free to reach out to either of us and we can get back to you. Otherwise, we are right at the top of the hour. Thanks everyone for attending today. And let me just go ahead and bring up the futures here. June 18th, July 16th. There, look at that, went to present mode. June 18th and July 16th are our next two sessions. And then don't forget, Simio Sync, less than a month now, May 14th and 15th. Please go to our website to sign up. Thanks, everyone. Drew, good job. And we will see everyone hopefully at Simio Sync in less than a month. And again, at our solution series in about 2 months. Goodbye.